Welcome learners, this is Module 5 of Unit 1 Engineering Geology, Plate Tectonics and Earthquakes. In this module, we will be seeing plate tectonics, elastic rebound theory, earthquake and its waves, earthquake intensity and magnitude, seismic maps. So first we will be seeing what is plate tectonics. In 1915, the German scientist Alfred Wegener proposed the idea of continental drift. He proposed that initially all the landmass of the earth were combined together and was represented in a single mass called Pangea. Similarly, the water surface are all combined together, mentioned as Peninsula. It was 200 million years ago, and due to plate tectonic movements, due to the movement of plate tectonics, the crust layer, this single mass of land got separated into what it looks like today. I will show you a small video about how the transformation has occurred. Again, I will pause it and play in a slow motion. As you can see, initially all the land masses were combined together and it was called Pangea, and all the water masses are present in a single entity which is called as Peninsula. Due to plate tectonics, due to the movement of plates, the land, the crust layer got separated as shown in the video. Now at present our world looks like that. He has given evidence to support his idea. The first evidence is geological evidence. The North American continent and the South American continent and the African continent exactly merges. So this is one of the geological evidence he has given. Also he has given fossil evidence. The fossils that are found in South America and Africa are similar, and also in India, Africa and Antarctica are all similar. So based upon these two evidence, he told that he proposed his theory, but he could not explain what are the forces that is causing the tectonic plates to move. So as I told, Alfred Wegener could not find the force that was causing the continents to drift. Because of this, he could not convince anyone that continents could move. Later, it was found that the convection currents acting in the mantle may create sufficient force to move the plates. As shown in the top figure, the hotter, less dense liquid will try to go upward, forcing the top higher density cold water to come down. This is what happening in the mantle. In upper mantle, you have high density colder liquid, whereas in lower mantle you have less density hotter material. So the less density hotter material will try to move upward, whereas the high density colder liquid will try to move downward. This will create a convection current in the mantle. As the liquid moves in the mantle, it creates a shear force along the tectonic plates, which causes the tectonic plates to move. Since the crust, the rocks of the earth's surface rests on the tectonic plates, the crust also move along with the tectonic plates. So these are the different types of continental plates. The main continental plates are African, American, Antarctic, Indo-Australian, Eurasian and Pacific plate. Apart from this, several smaller plates also exist, like Andaman Plate, Philippine Plate. Elastic rebound theory. So, as I told before, due to convection current, the plate moves. As the plate moves, the crust also moves. As the plate moves, the stress is applied to rock. Once the stress is applied to rock, strain energy is created and it will add up till it breaks. Eventually, rock ruptures and energy is released as heat and seismic waves. This is what we called as earthquake. So, this is the initial A and B are rocks. It is in normal state. As the plate moves relative to one another, the strain develops as shown in the red curved line. As it reaches its capacity, it breaks. Once it breaks, the strain energy stored releases in the form of heat and waves. These waves we call it as earthquake. The point inside the earth surface where the rupture takes place is called focus, and the point directly above the focus on the earth surface is called epicenter. The relative distance between which the rocks moved is called amount of slip. Earthquake terminologies. So, as I told before, the location on a fault where earthquake rupture initiates below the surface is called focus. The point on the earth surface directly above is called hypocenter. The point on the earth surface directly above the focus is epicenter. Here it is given as hypocenter. Note it down, it is not hypocenter, it is focus. Hypocenter, it is the calculated position of an earth focus. This is another figure depicting important terminologies of earthquake. Focus, fault plane. Fault plane is the plane where the displacement occurs. Focus is the place below the earth surface where the energy releases. Epicenter is the point directly above the earth surface, directly above the focus in the earth surface. Earthquake waves. There are two kinds of seismic waves: body waves, surface waves. Normally, the energy is released inside the earth. Waves that move through the body of the earth are called body waves, and waves that move along the surface of the earth are called surface waves. Body waves also have two kinds of waves. First wave is P wave. It's a tension compression wave. It is also called tension compression wave. It moves with a velocity of 6 to 8 km per second. It moves parallel to the direction of the movement. It is also called primary waves. It is similar to sound waves. The second type of body waves is S waves, shear waves. It travels with a speed of 4 to 5 km. It travels perpendicular to the direction of the movement. Also called secondary waves, result from the shear strength of the materials. It does not pass through liquids. So the first figure is the propagation of P wave. As you can see, the square boxes the size of the square boxes decreases and elongates. So the P wave is also called tension compression waves. There is no waveform in the direction of P wave. So the particle will be moving to and fro along the direction of P wave in primary waves. Whereas in S waves, the square boxes remain square. The particles will move up and down perpendicular to the direction of propagation. Surface waves also, there are two kinds of surface waves. One is love wave, another one is Rayleigh wave. Love wave is similar to P waves, whereas Rayleigh wave is similar to S waves. Whereas the difference is it diminishes when you go below the surface of the earth. These waves travel slower than S waves and are formed as P and S wave energy hits the surface. As I told, Rayleigh wave, it occurs predominantly on the surface of the earth. It is similar to primary waves, tension compression waves. As you can see in the boxes gets compressed and elongated. Love waves are similar to S waves in the form the particle moves up and down perpendicular to the direction of the motion. Similar to Rayleigh wave, it diminishes when you go below the earth surface. How earthquake is measured? Earthquake is qualitatively measured in intensity scales, for example modified Mercalli, whereas it is measured quantitatively in magnitude scales, for example Richter scale. So earthquake is measured both qualitatively and quantitatively. First type is qualitatively, which is measured in intensity scales. Second one is quantitatively, which is measured in magnitude scales. So intensity scales, it is based on damage and human perception, whereas in magnitude scale it is based upon amount of energy released. One of the popular intensity scale to measure earthquake qualitatively is modified Mercalli. It is a 12-point scale where the first reference it is not felt by the earthquake is not felt by the people. Second is felt only by persons at rest. Similarly, for each individual scale, qualitative assessment is given. Based on the qualitative assessment and damage, the earthquake is assigned to a particular scale. Second, magnitude scale. This is how the earthquake is measured quantitatively. Richter scale, amount of energy received 100 km from the epicenter. Till now, the largest earthquake ever recorded is 8.9 Richter. Normally, earthquake less than magnitude 2 in Richter scale are not felt by people. The Richter scale is not a simple arithmetic, it is logarithmic scale. So, if we increase 1 unit in Richter scale, it means 10 times greater shaking and 30 times greater energy. This is the seismic map of world. In this map, it is shown that areas which are more prone to earthquake, the areas where earthquake will be very large. The intensity of earthquake, the probability of earthquake increases from white line to the brown line. If the area in the world is in white line, then the occurrence of probability is very less. If you go through green, again another green, yellow, red and brown, the probability of occurrence of earthquake increases and it is highest for brown color. As you can see, almost 90% of earthquake occurs at the plate boundaries. So this is the seismic map for India. This is the map given for seismic calculations by Indian Standards IS 1893. Indian Standards IS 1893 divided India into 4 zones, whereas zone 2, the probability of earthquake coming is lesser compared to zone 5. In zone 5, the probability of earthquake coming is higher. So here the blue line is zone 2, yellow line is zone 3, green line is zone 4 and rose line is zone 5. Thank you.